So there's a real physiological soundness to this as a parameter, and it's quite important that really if you're doing any form of exercise testing, that you don't use one method in isolation. You need to identify the aerobic capacity. Don't just use the blood lactate data. We've learned in previous sessions that actually blood lactate data on its own is pretty unreliable, particularly if you're using visual inspection. It's very, very poor. You may try and ameliorate that by using some kind of method, either using like a log-log transformation on the data, or people tend to use things like something like a Dmax test or whatever. But we clearly have issues of both validity and reliability with the lactate data. But we can confirm that response by taking the lactate data in conjunction with the gas exchange data. So by identifying gas exchange threshold, we're fundamentally confirming the lactate response. But unless we've got the lactate data, we cannot confirm the gas exchange threshold. We need both. It's kind of a double confirmation. And so here we've got the three kind of big parameters that one would absolutely recommend to use. We've got our blood lactate data. I've put these lines in here really just to kind of signify the acceleration. You wouldn't normally do this, but it's quite a useful thing to do in terms of this teaching aid. Here's the V slope from Beaver, which is the original idea that's been done. You can do this with Douglas bag data and breath by breath, and then the ventilatory equivalence. Now, this brings us to an incredibly important paper published actually over 20 years ago now. And I think it's one of the most underrated papers within the field of exercise science. This is by Gaskell and colleagues. The reason it's so important is that the authors absolutely fundamentally recognise that in isolation, any of these is actually potentially an unreliable measurement. This is actually notoriously quite hard to identify. I'm going to flip back and just show you. If we look at this data here, which is in breath by breath, it is quite hard to see. The only reason you know it's there is because the authors have been very kind and put these lines in. It's quite difficult to see. With Douglas bag data, if you have too big an increment in workload, you're going to miss the parameter. You know, it's fundamental. It's an issue that we've seen in max testing as well. So on their own, they are actually potentially quite difficult to use. And Gaskell's statement was really clear. Use them in combination to confirm, to support the validity of your identification. And they write this, and this is actually from Paul and colleagues, but it helps kind of support what Gaskell is stating, which is this. Specifically, gas exchange is measured in the range of approximately once every 2 to 4 seconds if it's breath by breath, depending on the breathing frequency of the participant and gas exchange threshold. Now, if that is Douglas bag data, that doesn't quite apply, because within a Douglas bag, you will in essence take the entire sample for say 60 seconds. Gas exchange occurrence is independent of ramp incremental protocol. That's quite an interesting point. There's a group actually out in Portugal at the moment who are investigating this, and they have a suspicion that that may not be the case. And to a certain degree, you wonder whether it is effective. But Paul is suggesting actually it doesn't really matter what your protocol is. It doesn't really affect the gas exchange threshold. You certainly don't need to get a steady state. And actually, if one goes with their notion, if VO2 is proportional to exercise intensity and CO2 is proportional also to the VO2 and V is proportional to CO2, it doesn't necessarily matter whether you're at steady state. They all follow a similar response at the onset of exercise. But they state, although a false negative, i.e. the false observation that the gas exchange threshold was absent, can occur if the rate of increase in power output is slow relative to the participant's aerobic fitness. So you need to be very specific in making sure that you don't have an overly slow rate of increase. So that is, for example, on the cycloergometer, we were going up in 30-watt increments for a relatively well-trained cyclist. Were I to go and say, well, I've got somebody who's less well trained, but I'm going to go for 15 watts because it feels like it's more satisfactory, actually you're more likely to get a false observation. A slow ramp reduces the sensitivity to identify the onset of threshold behaviour in the V-slope plot. However, it is important to note that gas exchange threshold occurs at the same VO2 whether the ramp is rapid, completed within 5 minutes, or slow, completed within 10 to 15 minutes. So where they're talking about slow and fast, they are kind of saying, well, actually, if you do a kind of conventional max test, which conventional tells us that it should be completed within 8 to 12 minutes. I wouldn't hold on that really, but if you do a VO2 max test that is kind of in the region of 10 to 15 minutes, which is normally what happens, and you do regular increases and actual stepwise increases in exercise intensity, you should get a clear indication of the gas exchange threshold, and you'll get a clear indication anyway of the blood lactate response. But when we then look at the Gaskell paper, what they have is they say, well, you combine a number of methods. Now, they additionally add in what's called the excess CO2 method. Now, this is my kind of word of caution, is that I wouldn't recommend using excess CO2, primarily because excess CO2 is a bit of a mathematical fudge. There is no actual physiological rationale for the excess CO2. The excess CO2 method really relies on using mathematical computation to fundamentally calculate the square root of the VE, square root of the VE and square root of the CO2. So it feels a bit of a mathematical fudge. So in my mind, I would always recommend using the ventilatory equivalent, VE VO2 and VE VCO2, the V slope method, and then corroborating that with the blood lactate response. And they write this: the use of the combined method described here can substantially decrease the number of indeterminate tests, reduce error rate, and decrease the standard deviation of the difference between the lactate term point, the lactate data, and they've used VT. It's a phrase that you may come across, which is ventilatory threshold. But it's not really a ventilatory threshold because it's not ventilation that's causing the change, it's the gas, it's because it's the CO2. So I'm always very cautious of using the term VT. The combined method used in this study provides a reliable and valid process for the determination of VT, gas exchange threshold, in healthy individuals over a wide range of fitness levels. And actually what their recommendation is that if the difference is less than 3% in terms of the workload difference, and that's really important using breath-by-breath data, if the difference in identification is less than 3%, then you've almost certainly got a reliable identification of the aerobic capacity, the gas exchange threshold.